In physics, we come across various machines, instruments, devices, apparatus. In the study of each instrument, device, apparatus, we need to learn certain things in common. What are they? Name of the scientist and the year of its invention. Principle, it may imply one or more principle. Construction, drawing, working, limitations, least count, efficiency, uses, and problems. Let us take this as a framework to study any device. Now, we shall see Van de Graaff generator.
Van de Graaff generator. Van de Graaff generator is a high voltage electrostatic generator designed by Robert J. Van de Graaff in the year 1929. It produces a large amount of electrostatic potential difference up to 10 million volt. Principles of working. It works on the principles of action at points or corona discharge and electrostatic induction. Construction. A large allospherical conductor is fixed on the insulating stand. This allospherical conductor has large number of free electrons and positive charges, and thus the allospherical conductor is neutral in charge. A pulley B is mounted at the center of the allosphere and another pulley C is fixed at the bottom. A belt made up of insulating materials like silk or rubber runs over both the pulleys. The pulley C is driven continuously by the electric motor. Two comb-shaped metallic conductors E and D are fixed near the pulleys. The comb D is maintained at a positive potential of 10 to the power 4 volt by a power supply. The upper comb E is connected to the inner side of the hollow metallic sphere. The molecules present in the air between the belt and the comb are electrically neutral in charge and shown as the positive and negative charge enclosed within the ellipse. Working. Positive charges from the positive terminal of the power supply accumulate at the sharp edges of the comb D and produces high electric field. Due to this high electric field, the air between the belt and the comb D gets ionized due to corona discharge. That is, the neutral molecule present in the air between the belt and the comb D splits up into positive and negative charges. The positive charges are repelled and ends pushed towards the belt and negative charges are attracted towards the comb D. The positive charges stick to the belt and move up. When the positive charges reach near the comb E, electrostatic induction takes place. Hence, a large amount of negative charges are induced at the sharp edges of the comb E and positive charges move farther away from the comb E and reach the outer surface of the sphere. At the same time, the negative charges nullify the positive charges in the belt due to corona discharge. When the belt descends, it has almost no net charge. At the bottom, it again gains a large positive charge. The belt goes up and delivers the positive charges to the outer surface of the sphere. Limitation. This process continues until the outer surface produces the potential difference of the order of 10 million volt, which is the limiting value. Charges cannot be stored beyond 10 million volt since the extra charge starts leaking to the surroundings due to ionization of air. The leakage of charges can be reduced by enclosing the allosphere in a gas-filled steel chamber at very high pressure. Uses. The high voltage produced in this Van de Graaff generator is used to accelerate positive ions, that is protons and neutrons, for nuclear disintegrations and other applications. Dielectric strength of air is 3 into 10 to the power 6 volt per meter. Suppose the diameter of the hollow sphere in the Van de Graaff generator is 1 meter. Calculate the maximum potential difference created by this Van de Graaff generator. Whenever we come across a problem in physics, we need to carefully go through the problem to identify the value of the given physical quantities and think over to apply appropriate formula to find out the answer. This is the Van de Graaff generator. In this problem, the diameter of this hollow metallic sphere is given as 1 meter. The dielectric strength of the air is 3 into 10 to the power 6 volt per meter. We need to calculate the maximum potential difference created by this Van de Graaff generator. Given the dielectric strength of air is equal to 3 into 10 to the power 6 volt per meter. The diameter is 1 meter, hence we can calculate the radius of this hollow sphere by dividing the diameter by 2. So the diameter is 1 meter and the diameter of the hollow sphere is equal to 1 meter, hence the radius of the hollow sphere equal to r is equal to 0.5 meter. So these are all the given values in this problem. We know the electric field on the surface of the sphere by Gauss law is given by E is equal to 1 divided by 4 pi epsilon 0 into Q divided by R square. The potential on the surface of the allosphere is given by V is equal to 1 divided by 4 pi epsilon 0 into Q divided by R, which is equal to E into R. That is V equal to E into R, because the value of E is equal to 1 divided by 4 pi epsilon 0 into Q divided by R square. Hence, V equal to E into R. Now, we need to apply the appropriate formula. The maximum potential that could be created by the maximum electric field is given by V max equal to E max into R. We know the value of E max, that is the dielectric strength of the air, which is given as 3 into 10 to the power 6 volt per meter, and the radius of the metallic sphere equal to 0.5 meter. If we apply this value in this formula, then the maximum potential difference created is given by V max equal to 3 into 10 to the power 6 into 0.5. If we multiply this 3 into 0.5, we will get 1.5. So 1.5 into 10 to the power 6 volt or 1.5 million volt. Hence, the maximum potential difference created by this Van de Graaff generator V max equal to 1.5 into 10 to the power 6 volt or 1.5 million volt. That is the required answer.